Alright, this is Shane and this is the second video for the project. And today we're gonna make the release or the release trigger on this script. Okay, so I have this part made here already, and just to give you an idea of what we're going to make. Alright, so first let's talk about the overall modeling ideas. So this thing is pretty hard to extrude or revolve. And it's not even it's it might be able to extrude and use some different perpendicular extrudes to get the intersection and edge blend. But there's a better tool. So once you look at some geometry like this, you probably get a feeling it's something with a lot different cross sections. So if you recall what we did from lab 3, and that's the tool we introduced, it's a sweep tool. So today we're gonna use sweep or swept for this part mainly, and you can take a look at the slides. Those are the different cross sections, and the last step it'll just be a simple extrude to cut this hole. Okay, so let's take a look at the different sketches. So those are those sketches, and those sketches are built on different datums. Okay, if I turn this to static wireframe, and you can see they're on a path or the guide curve for the swept. Okay, and so it's like a spine. This is like your spine, and that's like different cross section of this model. Okay, so let's build a new file. It'll be inch model, and someplace you can have access. Alright, now let's build the sketch, the first sketch first, which has the guide curve as well as circle for the hole. So as we said, the z direction is the thickness or the height direction. So this guide curve, I will build this sketch on the xy plane. Okay. Now let's drop in this circle first, which has a radius of the diameter of 1.4, 0.14. Yeah, should be 0.14. And that's way too small, so I just Control F. Okay, fit. Okay, again, this CAD is not hand drawing. So the next step, I will start from the general geometry. If you look at here, this little zoom in picture here is actually the fillets. That's why you got this point here, because that was a corner before then I made a fillet. Okay, so this gives me some idea how I made this. I made this straight line, and that straight line there's an arc connecting both of them. So what we can do, we can use profile tool, or you can use straight line, a line here, a line there, and 3-point arc. That's one way, and make the top corner a tangent. That is one idea. And the second one is you can use profile tool. Go down here and change that to arc, so it'll be tangent automatically. Come down here and it'll turn back to straight line right away. Okay, so that's pretty much what we have here. Then we can add dimensions second, and always leave the fillets to the last. Okay, now dimension, we can follow the order here. We can start from P1, which is the distance between the bottom vertical line to y-axis, 0.36. Okay, and this line goes to the right side, so I'm going to drag this back to the left side. Distance between them, 0.19. Hit enter. Then the vertical dimensions, and that'll be the top point to x-axis, 0.85. Then the bottom point to x-axis, 2.05. And there's this dimension P2 is from this intersection point to x-axis, which is 1.65. Hit enter. And lastly, this intersection, the tangent point here, if you zoom in, you can see that's actually a there is a point on curve constraint, which means this point is on the x-axis. So we're going to use a geometric constraint, point on curve. So I'm going to pick this point to constrain to the x-axis, and you can tell the color changed. Okay, so it says sketch fully constrained. Alright, now I have enough dimension on the screen. The next step, and also the last step, the fillets. And the radius is 1 inch. Hit enter. If you zoom in, that's the constraint still there, point on curve. Okay, finish sketch. That'll be our guideline, and we have all the cross sections that's normal on this curve. Alright, so next step, we'll create those datums for the cross sections. We actually have 1, 2, 3, 4, 5, 6, 7, 7 cross sections. We will make 6 datums because one of the sketch is on XZ plane, so we don't need an extra datum for that. Okay, so we're gonna start to create a datum plane, and the method or the type will be on curve. So that's because we want the datums to be normal to this path. So the orientation here is normal to the path, which is the default. Now I'll click here, and the first point would be the end point. Of course, you can type in 0 here. Okay, and the size of the datum doesn't matter because it's an infinite plane. That this is just an indication telling you there is a plane, but the reality is this is infinite. Okay, so you can change your size as you wish, and we can click apply and move to the second datum. Did I click apply? Okay. Yeah, the second datum is 10% from the top. So I'm going to click. If you click the top half, then X will think the top is the starting point. If I click here now, the bottom, and you move it here to 10%, that's actually 90% from the bottom. So depending on where you click, you need to either type in 10 or 90%. Okay, and the third one will be XZ plane, so we're gonna skip that one. The fourth is 50%. Apply, and click here. That'll be 70% from the top, so it's 30% from the bottom, since we click the lower half of the curve. Then we click here. Somehow it's thinking the top is the starting point, so now it's 90%. And the last one is, okay, click apply first. Last one is the very end. Okay, You can see the different size of the datums because when you zoom in, it'll create a datum that's always this much on the screen. So next step, the different cross sections. And as you can see from this picture, we have 7 different cross sections. Okay, now if you look closely, the first 2, they're actually the same, and also these 2, they're the same because they're between transitions. So you want 2 the same cross sections to constrain that section, and from between different cross sections, there's actually transition between them. Okay, so we're gonna start from the top. We're gonna name this datum 0% and 10%. So for those 2 datums, they're the same. And here's something when you create a sketch. So let's create a sketch on the first datum. And you notice the sketch origin is not on the curve. Okay, not on this intersection curve. And sometimes for our application, you want to have a point where you know this is the intersection of that curve in your sketch. So we're going to change the sketch origin to use this point on curve. So we're going to pick a point on this curve, and it'll project this point onto our sketch plane. So in this case, because this section is a straight line in our the first sketch, so no matter where you click or how you change your point, it's always the same place. Okay, so if you like to, you can say arc length percentage 0%, because that's the 0% datum. So click and hit enter. Now that's your sketch origin, and hit OK. Now for this kind of sketch, I would prefer to draw the sketch from an angle, so I don't mess up with other sketches. The other way is you can hide other datums to have a clear working space. Alright, now let's look at the first sketch. The first sketch is basically a rectangle with the dimensions 3 30-seconds by 5 30-seconds. And one thing you have to pay attention to is I want the left side to touch this guide curve, and also this should be symmetric on the x-axis. So don't worry about the dimension now, just insert a rectangle, and of course you can type in the width and height right now, or you can add dimensions later. So if you prefer, you can say the width should be 3 30-seconds, hit enter, and the height is 5 30-seconds. Okay, and now the shape is fixed, but I can still move the thing around. Just click. So next, we have dimension for this box, but the position of this box is not fixed. We need 2 constraints. First, you want this line to be on the intersection point. So a line on a point, that will be the constraint, which we use often, that's point on curve. And you can say I want this point or this curve to be on this point, the sketch origin. Okay, now this can still move up and down because this point is on the curve but not in the middle. So next, a midpoint. So I want the sketch origin to be the midpoint of this line. Constraint to the sketch origin. Now it says fully constrained. So we're good to go for this sketch. And next sketch, build another one on the 10% datum. And you notice the Z is pointing the other direction. We had that vertical axis is going up for the first sketch. So I'd like to reverse the Y. However, X reverse too, because this is a right-hand system. So you want to reverse the normal of your sketch, then reverse the vertical axis. So this will give us X and Y like exactly the same as the first sketch. However, we still need to specify your sketch origin. So I would use point on curve, pick this point, and again this is a straight line section, so no matter where you click, it'll be the same projection in your sketch. I just say OK and rotate to some angle. So the second cross section is exactly the same as the first one. You don't have to draw this. What you need to do is, I think I wrote this in the slides. Okay, make it smaller. The same. Okay, I didn't say that because I thought you don't need a lot of effort to draw a rectangle. And we have a shortcut here. If you come down here and expand into this menu, there's project curve. So basically you're gonna project some curve from other sketch or other solid. So we're gonna project not one curve but connected curve from the first sketch or the first section into this current sketch. If you hit apply, now that's the projected curve, and this is associative. So if you change the dimension in the first sketch, this will change following the first one. That's why the color is different, because this is associated to the first section. Okay, so we can simply just finish this sketch. We don't need dimensions because it was determined by the first section. Now the third sketch is where your geometry starts to become a C shape. So first glance at this geometry, it's basically a C shape, and this is the part is a sheet metal. Okay, so that means this is uniform thickness anywhere. So if it's a uniform thickness, I can use a tool called offset, which is this heart shape. Okay, and I have to create a sketch first. So sketch on the XZ plane. That's the XZ plane. And you can change your sketch origin to be on this curve. Okay, I'll show you how to do this. Again, that's a point on curve, and you can pick a point here. Now this time, if you pick a point, let's say, if you click here, you can see that's the origin because it's projecting this point onto your XY plane. So if I move this point, actually you want to move this point, that'll be on touching the guide curve, and this is the straight section, so no matter where you click, it'll still be here. Okay, and the other way is like what we did in the slides. You can project a point, which is intersection point. Click the line here. Okay, and if you move the cursor here, see we made a point from the projection. That's how you find the intersection point between from this curve that goes through your sketch. Alright, let's go ahead and make this shape. And a couple of things I noticed from the sketch. First, this is symmetric. Second, you want this point to touch the curve. So we have uniform cross sections. They all have their left side touching the curve. Okay, and the third thing is this is uniform thickness. We can use offset. So I'm gonna draw a C shape first, because now we're looking from an angle, so it'll look a little bit different. And also, I have a construction or reference line here. I would like to have this line there. Okay? So I'll draw a triangle first, and make sure this reference line is vertical. And as you can see, we have a vertical constraint there. If not, you can simply click and apply a constraint in this section. And now I'm going to turn this into a reference, so it will not involve in your the creation of solid body. Now what we do is we can add dimensions. Let's see, invert dimension 45 degrees. Okay, what the degree between them? 45. Don't worry if it's flying out. You can drag it a little bit, and I have this length of this reference line. It's actually the opening, the width of this opening of the C. So it doesn't matter here. I can just type in first 0.438. Hit enter. Next. Really no next. We can make a fillet here, because we need this P23 to be effect on the arc. Okay, so once we made the fillet, we can make the top and the bottom of this corner to be equal length. This time we will have the same degree, same corner top and the bottom. Okay, and the total width of this C shape is 0.33. So that's between this reference line to this arc, not the center point, but this arc. So if you have a hard time picking up this arc, you can always wait and click, pick this arc. That's the horizontal distance between them. So that'll be 0.33. Okay, so what do we need more? The shape is good, it's only the position. So it's symmetric. I'll use a midpoint constraint here for the vertical line, the reference line to sketch origin, which is on the curve. So sketch origin. Okay. Now if you drag this thing, it can only move left and right. And that's what we want. We want this arc to touch the guide curve. So another constraint, point on curve, we want this curve to touch the sketch origin or the intersection point. Okay, and now it's fully constrained. Now we're not done yet, but we have the outside of this C shape. And to achieve the uniform thickness, we can use offset curve command. So the thickness of this sheet metal is here, and NX rounded this up. The accurate dimension is 3/32. Hit enter, and you want to pick either single curve or tangent curve. You don't want to click on this reference line. So I can show you what happens if you use a connected curve. And okay, that's offset. I want to flip the direction. Either click here or double click the arrow. So it'll close this loop up. So that's different from what I want. I just want to offset the C shape, not the triangle. So I'll deselect this, and it'll deselect everything. I'll pick tangent curve because in this case my three solid lines, they are tangent to each other. Or I can use single curve, pick what I need, flip the direction, and you can see the difference. Now we can say OK. So all we need to do left is close this into a close the loop. Okay, fully constrained, that's a C shape. We're done here. And finish sketch. So all the C shapes are pretty much using this method. Okay. All right, now we can continue to the cross section at datum 50% and 70%. I think those two are the same. So let's see. Yeah, however, they are not parallel, so you cannot use project curve to get the same sketch. Anyway, we're gonna start. So with the experience for the sketch on XZ plane, it should be a little bit easier for us to start the sketch on this 50% datum. And again, you can set your coordinate system over there. So in this case, I'm going to show you if the coordinate system is not on the curve. Okay, again, I'm going to rotate out and sketch from angle. And then first, draw a rectangle with this vertical line. If it's not vertical, you can add another constraint for this line. And turn this to reference and dimension this 45 degrees. And the opening of this C shape is 0.390. Okay, and next add the fillets. You don't need dimension for the fillet because we're gonna have a dimension between the reference line to the arc. So that'll be the total width of this C shape, which is 0.2. And it looks funky. We can 45 degrees 0.39. Okay, if you rotate to this angle, it's a little bit looks like that. And next we're gonna make sure the top and the bottom is equal, so it's a symmetric geometry. Then we also want this to be symmetric on the x-axis. So constraint point on curve, which is not. We need a midpoint for this one to be have a midpoint that's sketch origin. Okay, and we can still move this horizontally. And now we want this to touch the guide curve. And to touch the guide curve, we need to find the intersection point of that curve on the sketch. So intersection points, click the curve, and that's the intersection point. And it's hard to see, so what you can do is you can click on the point. There's turn into reference. Now it'll make the point bigger and hollow. Okay. So it's a little bit easier to see now. Point on curve, I want this arc to be on the point here and fully constrained. So next we're going to offset the thickness. Offset is still on 30 seconds. And single curve, in this case I'm going to use tangent curve. It'll pick the whole thing. Double click, reverse the direction. Okay, now all you need to do is close up. and finish, fully constrained, finish sketch. Okay, and for the next sketch here, do the same thing. Okay, now you can tell this normal is different now. Normal is pointing to the top right corner, and if we go back to this, the Z is coming out of screen towards us. Okay, and if you create a sketch on this datum, Z is going into the screen. So again, you can double click and flip the Z to get the appropriate axes. Okay, now it's the same as this sketch. Of course, I can go to next slides. First, the profile tool, triangle. Now, in this case, my supposed to be vertical line is not vertical, so I just click this line, turn this to vertical, and click again to turn this to reference. And that should not be a perpendicular constraint. It's automatically added. So delete that, and give this an angle at 45 degrees. And you can try to drag it. If it's not working well, just back up. And opening width of this C is 0.39. And let's make a fillet here. Okay, so it's not equal at the top and the bottom. And pick them up in this quick menu, make them equal. And now we can give a dimension between this to the arc, which is 0.2 inch. That'll be enough. And next, we need to find the intersection point of this curve inside our sketch. That's the point. So you can, if you have a hard time picking up that, you can right click, select from list, or you can hover your cursor and wait for the 3 dots and pick up this arc. Okay, however, you actually need to pick up that point. Click, then we have this convert to reference. Okay, that's our point. Then we add some constraints. First, you can want point on curve. Okay, I want this arc to be on this point, and next the midpoint. So I want the reference as a midpoint of sketch origin or the intersection point. It's the same. Okay, that intersection point is definitely on the x-axis, as you can tell from here. Okay, now that outside C is finished and offset, the same distance, the same curve method. Let's click here, reverse, then close this up. Finish, and next. Okay. So that's the 90% cross section. This time it's a C shape, but it's actually an arc, so it's much easier than previous C shape. So all we need to do is insert a 3-point arc. So if you use the arc tool, by default it's on this setting, arc by 3 points. So again, that's the starting point, end point, and 1 point in the middle. Okay, now we still need to add this vertical reference line. So this way we can make this symmetrical on x-axis. And turn this to reference, and now we need to add the 2 dimensions, which is from this line to the arc. That's the width of this geometry, 0.18. And the height of this geometry is 0.6. Hit enter. Okay, now we need to make this symmetric on x-axis, and geometric constraint midpoint for the reference line to sketch origin, and we need to make this arc touch the guide curve. So intersection point for the guide curve inside this sketch, find that point, turn this into a reference, and geometric constraint point on curve. I want this point to be on this arc and fully constrained. Next, just offset this at the same thickness. Finish. Close this up. Okay, that's done for this. Then the last one is simply another rectangle. So create a sketch on this. Define the sketch origin. So this time also we need to flip the Z to get your vertical axis going up. And I don't really like this position. I'll just pick the end point of this curve. Okay. Now rectangle tool, anywhere, dimension. Okay. Height is 0.43. The width 0.094. Okay, then we use constraints to make this to touch the sketch origin, which is the guide curve. Then we use midpoint for this to sketch origin. Okay, now it's fully constrained. We're done. So now we have 7 cross sections as well as the guide curve. Okay, and by the way, if your guide curve is not tangent, that swept tool will not perform well. It will not pick up the whole guide curve. Okay, now I will hide the datums to make this graphic window a little bit cleaner. Alright, now here is the swept command. Okay, now I'd like to, first you have to be on Advanced with full menu to see this list, otherwise it's not there. Second, I prefer to open this list so I know how many cross sections I have. It says section, that's actually cross sections. Okay, so I have 7 here. So I'm gonna pick the first one from, okay, you have to pick them in order. Then you have to play with the curve rule. I think by default it's tangent curve. So we're gonna pick connected curve because this loop is not tangent. And you have to select the top curve on the left side. If I pick the right side, this curve will go counterclockwise. Look, if I click here, the arrow goes counterclockwise, and we can flip the direction of this loop. And this time, the direction does matter in swept. If you notice in revolve and extrude, maybe not extrude, but in revolve you do have a direction of your loop. Okay, anyway, also there's origin curve. Okay, we can keep the first section like this, but I'm gonna come back and then change that. So we need to add another cross section for the swept. That's a new set. So each section will be a new set. So after you pick the first section, you have to click here, add a new set. Then I can pick a second one. And I do want this to be my origin curve because remember we have 330 seconds, the same here, thing here, the same. On each section we have a 330 seconds as the thickness of this sheet metal. So that I want them to align together, those thickness curve. So you notice the difference between those two sections. The first one, it starts from this vertical curve. So I want to change the origin curve back to the top. And again, I'm going to click on the left side of this curve to make the direction clockwise. So now that aligns well. I want to keep it this way. And add a new set for the third section. And I would click also on this 330 seconds and the left part of this. So now that's clockwise. And keep going. Click here. Going, click here. Okay, here I'm gonna actually make some bad judgment. I'll pick this as the origin curve and we'll see what happens. Then add another section here, add the last section here. So swept will keep those origin curve aligned. It'll make a surface from this top curve to this top curve. So from the origin curve, then you would think this actually we can look at this, and you can notice this surface goes through those 330 seconds curve. If I have this origin curve here, this surface will actually twist and go down inside the C shape, and we'll see in a minute. So the guide curve, you can simply just click 1 because we have only one, so that's pretty easy. Okay, so now you notice something. The bottom looks fine. Inside is somewhat okay, but here there's a big twist. Why? Because the origin curve, but this surface is trying to match a curve inside the C, which is not good. So what we can do is we can go back to that section. I think it's the 4th. That's the 5th, and specify the correct origin curve. Now you see this is much better. Okay, and the interpolation by default is on linear. Take a look, that's very sharp. You don't want that, so you want a cubic. And some of you find out that blend is really smooth. However, if you look at this corner, it's way too smooth. So it actually goes up a little bit, and the real thing is straight at the tip. So I want not too smooth, not too linear, but cubic is the best. Then this alignment, we need to change that, because if you look at here, the surface is not good. The bottom is actually okay, but here the surface splits. You want a continuous surface from this line to this line here. And if you look at the back, there's a twist. That's not good. So if I change that to bipoints, see, this is very smooth here, and all this thickness surface that goes very smooth from all the origin curves. Okay. And in this bipoints, you can actually align different points. So if I hover here, you can see so those points are aligned to each other. If I hover here, right? So from this picture, you can also tell how swept works. It'll actually scan the same point on different cross sections along the path. So that's good for this part. Just click OK, and that's smooth. And next I'm gonna use edge blend to make this tail into around the geometry. So edge blend the top and the bottom. Now we have overlapping, so you can use smaller radius. Usually that's good enough here, but if you want to play with this command, you can expand this variable radius, specify a new location. We can, as you can see, we have different depth here, left and right. So we can define this edge blend on the left side of this edge and the right side of this edge to have different radius. And also that goes the same to the bottom. Okay, and so we have 4 individual radius you can play with. You can simply just drag these arrows to make this edge a little bit better. Okay, so now you can make them bigger. 0.23, 0.23, and 0.4. I'll try to make it 0.4. They affect each other, so as you can see, as I change the left side, the right side also changes. Now let's try to make it even bigger. 33, 33. Make it bigger here. Now it's going away, so maybe it's too big. Don't be too greedy here. Okay, 27 is good, so I'll go 27. And that's aesthetic, so as long as you feel this looks nice, that'll be fine. Okay, so I don't want to see so many cross sections on my solid, so I can just shift and click. It's like Windows and multi-select, then hide. Alright, now the next or the last step is to make this hole. Simply use and extrude, pick this arc. I have this on this region boundary curves, so that means area. It works well here. You can also use inferred. It's probably going to extrude that guide curve, so you don't want that. You want connected curve or single curve just for this little circle. So I want to extrude this symmetrically because this sketch is in the middle of this solid. Symmetrically make it longer than your solid and fully intersected. The boolean I want subtract from the swept solid and click OK. So that'll be this vice grip, the release of this vice grip. This is the end of this video. If you would like to, you can add some little aesthetic edge blends if you would. It's purely just preference. If you would like to make it look nicer, apply. And if you want to get some rendering like this, you can do right click and choose shading. Okay. So it might be a little bit nicer looking. Okay, that's all for this video. Thank you.